Hi there, I'm Alia. I'm the full stack instructor from Integrify, and today we will discuss the topic of data structures. Whenever we talk about the seamless operations behind the applications or the websites, data structure plays the magic behind. I know sometimes it sounds really daunting when we talk about structures or algorithms. However, in the video today, we would crack the code together and we would try to make data structures as approachable and enjoyable as it could be. So let's start. Much like our closets, in the digital world, we have tons of data. And to make sense of this data, we use something called the data structures. Imagine if your closet was always organized, shoes in the racks, clothes neatly folded or hung, accessories in their compartments. You would find everything easily, right? That's precisely the role of the data structures in computing. They help organize and store data so that we can access and use it efficiently. Think of a stack of pancakes. The last pancake you put on the stack is the first one you will eat. So that's a stack in the data structures, the last in, first out system. Or consider a queue of people waiting for a bus. The person who arrives first boards first. That's a queue in computing, working on a first in, first out principle. Visualize a bookshelf. Each book has a specific position, and you can quickly grab any book if you know its spot. This resembles an array, where each piece of data has its unique position. Now you have the Facebook friends. Imagine a massive web where you're in the center and lines connected you to all of your friends, and then to their friends. This complex web of connection, well, that's a graph in the world of data structures. And lastly, think about your family tree. It starts with grandparents, branches down to their children, and further down to their grandkids. In computing, this branching structure is a tree, showing hierarchy and relations. But why so many types of data structures? Well, in different situations, we might need different solutions. It's just like using different compartments in your clothes. You wouldn't hang your shoes or fold your necklace, right? Similarly, in computing, different types of data have unique characteristics and needs. By choosing the right data structure, we ensure the most efficient handling of data. We have the common ways to define the categories of data structures, including the linear data structures and nonlinear data structures. So let's first explore the linear data structure. When we talk about the linear data structures, we are talking about the sequence of the data. First, we have the array. Picture a bookshelf where each book is in a specific slot, neatly numbered. That's your array, an order collection where each element can be identified by these positions or the index. Then we have the linked list. Think of it as the treasure hunt, where one clue leads you to the next location. Similarly, in the linked list, each item or node holds the value and a pointer to the next node. Up next, we have the stack. Imagine a stack of pancakes. You add the pancakes from the tops and also eat them from the tops. So this is the last in, first out way of handling things, and it is the essence of the stack. Finally, we have the queue. It's like waiting in line for a movie ticket. The first person in line gets served first. So this first in, first out approach defines a queue. Now let's talk about some common use case and some common operations that we can perform in the linear data structure. For the array, let's back to our bookshelf example. It would be perfect when you want to directly access to any book. By just using the index of the book, you can insert into the book array. You can access the book by the index. You can also delete or search for the book by the index. And for the linked list, the treasure hunt game, it would be great when the size can change and you're frequently adding or removing the items to and from the list. So you can insert, you can traverse, you can delete, and also can search for the items in the linked list. This stack or the pancake pile, when you need to work with the most recent item, like you need to undo the last action in the software, then stacks are your friend. The common operation in stack would be the insertion, the access and deletion, and pick. That means you can look at the top item without removing it. And lastly, we have the queue, the movie lineup. It would work wonders in situations where order is critical. For example, the print jobs. So we have it. From arrays to queues, understanding linear data structures can give you unique lens to see the world. Next time you're in the queue or scanning a bookshelf, you'll know that there are some computer science magic behind the scenes. So, moving on with the non-linear data structure. Remember that intricate spider web you saw in the other slide, with paths diverging in all directions, and that the essence of the non-linear in data structure. So in non-linear structures, it's not just a single straight line. Things can be branch out, move up, down, sideways. Wow, you get the drift. Let's dive into the popular non-linear data structures. First up, we have the tree. Think of it as an archer tree turned upside down. There's a root, branches and leaves, and in the world of computer science, each point is called a node, and it may have children. Then there's the graph. Picture a group of friends, all interconnected. Some are directly connected, some indirectly. Graphs are all about the points called the vertices, and the connections between them known as the edges. Some edges have the weight, as say you have some common friend, you have some close friend, you have the best friends. So the value of the edge can show the way of the relationship. Now let's discuss some use case and the common operations in the non-linear data structures. Back to our trees, they are the backbone of many systems like the folder structures in computers or the family trees. It has some common operations like the insertion, the traversal, the search, or the deletion. For instance, the family relation structure where parents have children and those children may have their own children is a classic example of a tree. Now the graphs, our interconnected friends, perfect for social networks like Facebook where everyone's connected somehow. So some common operations also include the insertion, the traversal, the search, or the deletion. Think of Facebook, you're a vertex, your friends are vertices, and the friendship connections, those are edges. From trees to graphs, non-linear data structure introduce a world of complexity, and beauty in organizing the data. So the next time you check your friend connections on the social network or map out your family tree, remember the non-linear structures working behind the scenes. As you can see, the beauty of computer science is all around us, often unseen but always essential. So keep learning and stay curious. Thank you for journeying with me into the heart of data structures. Until our next adventure, stay awesome and keep exploring.